Hey everybody, today we'll be talking about the GCSU Personalized Nutrition and Meal Tracking application. In our group, we have Alyssa Brock, Mecca Butler, Michael Hernandez, Tyler Jones, Michelle Ogbivre, and Peyton Smith. As a college student or faculty member, things that require extra effort, such as tracking your daily caloric intake or how much you have moved in a day, can seem more time consuming and less important when met with the challenges of day-to-day life. The proposed application will allow GCSU Wellness and Rec Center to create a user-friendly interface that will assist students and faculty with their fitness and nutritional goals. The application will have benefits such as providing the user with nutritional recommendations based on their individual goals, giving real-time feedback on the calories remaining in order to reach these goals based upon meals entered, and allowing the user not to only sync but view their fitness information and how they have progressed over time. The application will also benefit the GCSU Wellness and Rec Center by prompting a healthier lifestyle to those who attend or work at Georgia College and State University, but also allowing for a slight increase to student fees per semester in order to provide a premium product without the higher cost of monthly charges that are assessed with competitors.
Welcome to our Economic Feasibility Analysis and Feasibility Assessment Development section. First, let's look at the numbers. Our analysis shows that the cost of developing and maintaining our proposed solution are significantly outweighed by the projected benefits. We estimate development costs at $50,000 and an annual maintenance cost at $7,500. However, we project an annual revenue increase of $70,000, resulting in a net present value of $195,776,000 and a return on investment of 246.28%. We expect to break even within the first year with a positive cash flow of 7,561. But our analysis didn't stop there. We also conducted a thorough feasibility assessment, including interviews with key stakeholders, surveys of students and faculty, and in-depth research and analysis. Our findings were overwhelmingly positive. We identified manageable risk, determined that the system would enhance user satisfaction and operational efficiency, ensured compliance with data protection regulations, and gathered strong support from both students and faculty. The work completed in this phase aligns with the planning and selection phase of the SDLC. This ensures that we have clear goals and resource planning in place for successful implementation.
This stage was largely related to the first phase of the systems development lifecycle, as we were identifying how we could build this application to solve for a gap that the GCSU Wellness and Recreation Center was having, as well as the scope that the system should have. The information that we collected regarding the recreational center's current processes by examining the business documents that were provided in phase 2 or the systems analysis section of the SDLC. When interviewing Garrett, a graduate assistant at the Wellness and Recreation Center, we were able to receive feedback and move forward with a specific need that he mentioned, the need for an interface that was simple for students and faculty to use to track their fitness and nutritional goals. He also mentioned that it would be helpful if the application had additional capabilities that would make it easier to use and less time-consuming, such as a barcode scanner. This helped us develop a better understanding of what should be required. We were then able to create a DFD0 along with a context diagram that displayed how data moved between entities based on our business process analysis.
During this stage, our group was able to continue working on the second phase of the systems development lifecycle, which is the systems analysis phase. We were able to take the broader idea that we had and describe them in further detail using the data flow diagram level 1. While completing this section, the team worked through each process to describe in greater detail how the system would be functioning and how the data would flow between the processes and the entities.
Continuing with the second phase of the SDLC, we next completed conceptual modeling of our system. We used an entity relationship diagram to graphically represent the structured system requirements obtained in earlier phases of the SDLC. And going from process modeling to conceptual modeling, the data stores identified in our DFD0 were translated to entities for our ERD. We highlighted 5 entities that our system will store data about, and these are information related to user profiles such as name, date of birth, and dietary goals, a nutritional database that contains nutritional information on a variety of food and beverage options that may be logged by users, fitness history of the workout type, duration, and calories burned and workouts synced by users, meal history that stores nutritional information of the meals users logged to the system, and support ticket history that tracks the submission and resolutions of user issues reported to customer service. ERD assumptions were written and approved by users in order to explain the relationships between entities.
The third phase of the SDLC consists of two important activities, designing the human interfaces and designing a database. In order to design a mock prototype of the app, we use Balsamic to gain user feedback on its usability from students and faculty on the GCSU campus. We also use Microsoft Access to create a relational database needed to store information about the related entities identified in our ERD. To effectively create this database, we normalized it to the third normal form. This ensured that each column stored atomic values. Each table served one purpose, and there were no transitive dependencies between tables. By normalizing the tables, we aim to avoid data redundancy, minimizing data modifications, errors, and simplifying queries. With data stored in this logical format, the tables linked by primary and foreign key relationships, we constructed sample queries for management to quickly access important information, such as the types of food users are consuming based on their dietary goals. These are the 10 tables included in our Microsoft Access database. Each table represents a different entity within our system and is designed to store specific types of data.
As we move forward, there are several key steps we need to take to ensure the successful implementation of our nutrition and fitness app. First, we'll focus on coding and developing the key features of the app, including user authentication, meal logging, and nutritional recommendation. Next, we'll conduct thorough testing, including unit integration and user acceptance testing, to ensure the app is functional and user-friendly. Once testing is complete, we will deploy the app for GCSU students and faculty and provide comprehensive documentation, including user manuals and technical documentation. We will also offer training sessions, video tutorials, and workshops to ensure users get the most of the app. To ensure ongoing support, we will establish a help desk and FAQ session. Looking ahead, we will continuously monitor app performance, gather user feedback, and perform regular updates to ensure the system remains fully operational and meets user needs. By following these steps, we will successfully develop, test, and deploy our app and complete the final phase of the SDLC, system implementation and operations.